Jai Hind everyone, my name is Ankita Rani. I am working as assistant professor in the department of CSE at Ajay Kumar Garg Engineering College, Ghaziabad. Today we discuss about the topic virtualization. What is virtualization? This topic comes under the subject cloud computing and the subject code of cloud computing is KML051. So now let's discuss about the virtualization. Virtualization is one of the hardware reducing, cost saving and energy saving technology that is rapidly transforming the IT landscape and fundamentally changing the way that people compute. So in this the virtualization means how the multiple machines work on a single processor. So in this the multiple operating system works on a single machine. So this is the diagram of the virtualization processor. So in this, this is a hardware. The lower level is the hardware level. After hardware level, there is a virtual machine monitor, which monitor the virtual machines. And in virtual machine monitors, multiple operating system are installed like Windows, Linux, Mac. These all are the three operating system and these all three operating system works on the virtual machine monitor, and this whole process is called as the virtualization. In a multiple operating system, there are the multiple apps work on that operating system. So in virtual machine monitor, another layer of kernel to virtualize multiple operating system, and this process is also called as a hypervisor, in which the multiple applications are running. This process is called as the hypervisor. An operating system as a supervisor is no more hardware dictator. So this is the popular virtual machine software like VMware Workstation. This is the virtual machine software. Zen, VirtualBox, Citrix, KVM. These all are the virtual machine software. In this virtual machine VMware software are run. So this is the difference between the virtualization and non-virtualization. So before virtualization, we have a process of software developing, application monitoring, server management, network management, security management, data management, and too many COs. But after the virtualization, there is a software as a service, platform as a service, infrastructure as a service, data as a service, IT as a service, and green IT. So these all are the technology, these all are the services comes under the virtualization. So before virtualization, this is the architecture of before virtualization. In this diagram, you show that there is only one operating system, and this is the x86 architecture, and there is only one operating system and only one application is running on that operating system, and these are the cards like CPU, memory, network interface card, and disk. So in this, there is only single operating system per machine, and software and hardware are tightly coupled, and running multiple application on same machine often create the conflict. But after the virtualization, in this diagram you can see that there are the more than one operating system. In this diagram there are the two operating system. This is the first operating system, and this is the second operating system, and multiple applications can run on the different operating system. So this process comes only after the virtualization. So on operating system we have VMware virtualization layer. So in this this is the card like CPU card, memory, network interface card, disk. So hardware independence of operating system and applications, and virtual machine can be provisioned at any system. So this is the difference between the before virtualization and after virtualization. Before virtualization we have only single operating system, but after virtualization we have multiple operating system on a single machine. So we do virtualization because VMware share the centralized server, processor, memory and storage. So earlier 800 million unique server is working, but nowadays with virtual machine only 60 million server is doing the same work of 800 million server. So this difference comes after the virtualization. So this is the system model. This is the machine of non-virtual machine. In this, there is only one hardware, there is only one operating system, and there is only one application. But after the virtual machine, there is only one hardware, and after hardware there is a virtual machine manager, and on this virtual machine manager there are the three operating system, 1, 2, 3, and for each operating system there is a virtual machine, and different operating system we have different applications. So this is the difference show between this is the programming interface between the non-virtual machine and virtual machine. So how does the virtualization work? Basically, this is the diagram of the virtualization process, how the virtualization is work. First of all, virtualization layer is installed by using a bare metal or hosted hypervisor architecture. Bare metal hypervisor system does not require operating system, but hypervisor is required operating system. Bare metal hypervisor does not require operating system, but hypervisor require a operating system. So first we have a layer, hardware level, hardware layer. After hardware layer we have a hypervisor. After hypervisor we have multiple operating system. Operating system 1, operating system 2, operating system 3. Multiple operating systems are there, and for each operating system there are the multiple applications which run on that operating system. Next is what is hypervisor? Hypervisor or virtual machine monitor, both are the same things. So it is a piece of computer software, firmware or hardware that creates and run virtual machine. So hypervisor is required for running the virtual machine because on the hardware multiple virtual machines are installed for running the operating system. So a computer on which a hypervisor is running or more virtual machine is defined as a host machine, and each virtual machine is called as a guest machine. So hypervisor is a bare metal approach, and it is installed on the bare metal, and then the operating system is installed, and operating system is called as a para virtualized. So there are the two types of hypervisor, type 1 hypervisor and type 2 hypervisor. Type 1 hypervisor interact directly with the hardware. This type 1 hypervisor directly interact with the hardware that is being virtualized, but in type 2 hypervisor sits on top of the operating system. So type 2 hypervisor, it is on the top of the operating system, but the type 1 hypervisor interacts directly with the hardware that is being virtualized. So it is completely independent from the operating system, but type 2 hypervisor is dependent on the operating system, and so type 1 hypervisor boots before the operating system, but type 2 hypervisor cannot boot until the operating system is already up and running. So in type 2 hypervisor, if operating system crash, all end users are affected. But in type 1 hypervisor, they are often referred to as a native or bare metal or embedded hypervisor in vendor literature, because in bare metal hypervisor is not dependent on the operating system. But since type 2 hypervisor depend on the operating system, they are not in the fully control of the end user machine. So this is the diagram of the type 1 hypervisor. Type 1 hypervisor is also called as a bare metal hypervisor. So first of all, we have a layer of the hardware layer. After that, we have a hypervisor. Hypervisor is also called as a virtual machine monitor, VMM, because hypervisor or VM is both the same thing. After that, we have multiple operating system, and on that operating system, multiple applications are running on that operating system. So this is the diagram of the type 1 hypervisor. Next is type 2 hypervisor. So type 2 hypervisor, this hypervisor is depend on the operating system. So in this we have a layer of the hardware layer, and it is directly interact with the operating system because it depend on the operating system. So after operating system, multiple applications are running on that. After this, we have a hypervisor layer, and after that we have operating system, and for that operating system multiple applications are there. So this is the diagram of the type 2 hypervisor. So next is what is the difference between the type 1 and type 2 hypervisor. So in this type 1 hypervisor we have a virtual machine monitor, but in type 2 hypervisor we have a host operating system on the hardware. So this is the Zen VMware ESX server hypervisor, and in this we have the mostly for server but not limited, and in this we have a virtual machine monitor by default, and this is the operating system independent virtual machine monitor. But in type 2 hypervisor, this is the, in this we have a KVM and VMware workstation and virtual box, and this is for the mostly for the client devices. This is for the server. Type 1 is for the server and type 2 is for the client devices but not limited, and it is have a virtual machine monitor on demand. If the user need the virtual machine monitor or hypervisor, then they give the virtual machine monitor on demand. But in this we have a virtual machine monitor by default, and this is the OS independent, but type 2 is a OS dependent VM virtual machine monitor. So type 1 is independent of the operating system and type 2 is dependent on the operating system. So next topic is types of virtualization. First type is full virtualization. Full virtualization uses a special kind of software called a hypervisor, because hypervisor plays an important role in the virtualization. So full virtualization uses a special kind of software called hypervisor, because the hypervisor interact directly with the physical server CPU and disk space. It serves as a platform for the virtual server operating system. This is the diagram for the full virtualization. Full virtualization, we have a complete process of the virtualization technique, like Intel architecture, like hardware, and after that we have VMM, and after that we have a operating system and application for that operating system. So this is the diagram for the full virtualization. First layer is hardware, after that hypervisor, and the next is VM administrative console, guest operating system. Multiple operating systems are there in the full virtualization. Next type is para-virtualization. In para-virtualization, it needs to modify the guest operating system, and para-virtualized virtual machine provide special APIs requiring substantial OS modifications in user application, and the performance degradation is a critical issue of the virtualized system. So this is the architecture of the para-virtualization. In this we have a hardware layer. After hardware layer we have a hypervisor or virtual machine monitor, And after that we have a para virtualized guest operating system, because this works for the guest operating system. We have two para virtualized guest operating system. After that we have a application. So para virtualization is mainly work on the guest operating system. So this is the diagram for the para virtualization. In this we have a hardware operating host operating system. There after that we have a hypervisor. Next is we have a operating system, guest operating system, because in para virtualization we have only guest operating system, and after operating system there are the multiple applications runs on that operating system. So what is the difference between the full virtualization and para virtualization? In full virtualization, there is no operating system source modification. So in this, there are the software based full virtualization and hardware based full virtualization. But in para virtualization, there is a operating system source modification, because in this we have a guest operating system. So virtualization aware operating system, and it bridging the semantic gap between the virtual machine monitor and operating system, and this is the mostly for the performance. And today virtualization solution adopt both the approaches for optimized performance. Next is the server virtualization. Next type is server virtualization. In this we have a physical server, and creating multiple logical server operating system instances on one physical piece of hardware. This is the physical server. Physical server is divided into hardware, hypervisor, operating system, and applications. So this is the single physical server. This single physical server is divided into the three parts. First is the hardware, second is the hypervisor, and third is the operating system and applications. So in this we have creating a multiple logical server. We have created the multiple logical servers on one single piece of hardware, and hypervisor is installed on one physical server. This is the hypervisor installed, and multiple instances of server OS are installed. ये multiple instances हैं of the server. So this is the server virtualization. And what are the benefits of the server virtualization? First is host server connected over the SAN storage area network, and hardware fail tolerance, high availability, online live migration, easy management, disaster recovery, easily scalable, adjustable, different vendors, type, model servers, less hardware management, better efficiency with less cost, maintain average utilization. These are the benefits of the server virtualization. Next is the desktop virtualization. For desktop virtualization, in this we transform the desktop. So operating system and apps are decoupled from the physical device, and desktop run as a virtual machine in secure data center. So this is our desktop, and so in this we transform the static desktop to a stateless virtual desktop and connect to virtual desktop from thick or thin clients. So in this virtual desktop infrastructure is the desktop delivery model, which allow client desktop workloads to be hosted and executed on servers in the data center, and user can communicate with their virtual desktop through a client device that supports remote desktop protocols such as RDP. So this allow you to virtualize Windows desktop in the data center and deliver them on demand to any user. So these are the vendors of desktop virtualization: Citrix, Microsoft, VMware. So these all are the desktop virtualization vendors. And this is a desktop pool. This is the architecture of the desktop pool. This is the local client devices, and this is the virtual desktop in the data center. These are the different vendors: hosted shared desktop, PCs, and virtual machines. So what are the benefits of the desktop virtualization? First is centralized service pack upgrade, OS patch installation, OS upgrade from one version to the another version, highly available, fault tolerance, thin and thick provisional storage, and accessed via the LAN, WAN, internet and mobile connection, and offline use with the help of the VM player. And next type is application virtualization. In application virtualization, business applications run on servers located in the data centers. So in this, the servers which are located on the different data centers, applications are run, which is secured by the design, and one or more than one apps or more apps run on the same set of the servers, and it is the centralized application management, shared resources with maximum utilization, and it also supports the multimedia, and it reduces the licensing cost, and the role based user access controlled by the policies. So after application virtualization, next type is the hardware virtualization. In hardware virtualization, computer hardware virtualization is the virtualization of computers or the operating system. In this, computers or operating system are virtualized. It hides the physical characteristics of computing platform from users, instead showing another abstract using computing platform. So this is the architecture of the hardware virtualization. In this, we have a hardware, in hardware we have a CPU, memory, network interface card, hard disk. After that, we have a hypervisor. Hypervisor means virtual machine monitor like Zen and ESX server hypervisor. After that, we have a virtual machine and guest operating system, and the applications run on that operating system. So this is the architecture of the hardware virtualization. Next type is the CPU virtualization. In CPU virtualization, CPU architecture is virtualized if it supports the ability to run the virtual machines, privileged and unprivileged instructions in the CPU user mode, while the VMM runs in the supervisor mode. So CPU run on the user mode and VMM runs in the supervisor mode. And when the privilege instruction, including control and behavior sensitive instruction of virtual machine are executed, they are trapped in VMM. In this case, the VMM acts as a unified mediator for hardware access from different VMs to guarantee the correctness and stability. However, not all CPU architectures are virtualized. Next is RISC CPU architecture can be naturally virtualized because all control and behavior sensitive instructions are the privilege instructions. Next type is the input-output virtualization. In input-output virtualization, there are the three ways to implement the input-output virtualization. First is full device emulation. Second is para-virtualization. Third is direct input-output. So, input-output in input-output virtualization, generally this approach emulates well-known real-world devices. In emulation technique, in full device emulation, all the functions of a device or bus infrastructure such as device enumeration, identification, interrupts and DMA are replicated in the software. So this software is located in the VMM and act as a virtual devices. So we have a copies of the devices. But in para-virtualization method of input-output virtualization is typically used in Zen. It is also known as the split driver model, consisting of a front-end driver and a back-end driver. It achieves better device performance than full device emulation. Next is the direct input-output virtualization. This is the para-virtualization and this is the full device emulation. So in direct input output virtualization, let the VM access device directly. In this, we directly access the VM devices. So next topic is implementation level of virtualization. These are the levels of the virtualization. First is instruction set architecture. Second is hardware abstraction level. Third is OS level. Fourth is library level. And fifth is application level. In this, we have a bird architecture, dynamo architecture. In this, we have a VMware or virtual PC. At OS level, we have a jail, FVM, and SIMS. At library level, we have Wine. And application level, we have a JVM, Panot, and .NET. So, virtualization at a hardware abstraction level. This is the hardware abstraction level. We have a same concept: hardware, virtual machine monitor, virtual machine operating system, and application. Next is this is the virtualization at OS level. In virtualization at OS level, we have only one standard operating system. Next is the comparison between the different different levels of the different implementation level. This is on the performance basis. This is on the implementation complexity. This is on the basis of application flexibility, and this is on the basis of application isolation. So this is the providers for the virtualization solution and for the cloud providers. When we are talking about the VMware, we have Terramark, Tier 3, Bluelog, DataPipe. These all are the cloud providers. When we are talking about the Zen, we have Amazon Web Services, Rackspace, SoftLayer, GoGrid. When we are talking about the KVM, we have the cloud providers like IBM, Join, DataPipe, Elastic Host. These all are the providers, cloud providers for the virtualization solutions. Thank you.